amount of reactant left after n half-lives. This derivation will help you to solve the application level questions based on half-life period. If concentration A0 is the initial concentration of the reactant taking part in the first order reaction, we have amount of the reactant left after one half-life. That means one half-life, what will be the amount left behind, which is equal to half of concentration A0. This can also be written as concentration A0 by 2. That is, half means you can divide by 2 here and it can be written like this. Amount of reactant left after 2 half-life. That means this is for 1 half-life. Therefore, this keeping this as 1 half-life, multiply another with same equation with the half. That is another half-life. Half into A0 by 2, that is 2 raised to the power 1. That means here only 1 raised to the power. Put that so that we are going to arrive at a final equation. Therefore, now for the 2 half-life, it is equal to concentration of A0 by 2 raised to the power 2. That is, this 2 is counted and already 1. Therefore, 2 and this 1, that is 2 raised to the power 2. Amount of reactant left after 3 half-life. Therefore, consider this 2 first. Then again one more half-life means half. That is here 2 raised to the power 1. This is here already 2 raised to the power 2. Therefore, total 1 plus 2, that is 2 raised to the power 3, which is equal to concentration of A0 by 2 raised to the power 3. Therefore, in general, the amount of the reactant left after n half-life is equal to concentration of A0 divided by 2 raised to the power n. Thus, in a first order reaction, the amount of the reactant left at the end of n half-life, you can write an equation like this. That is 1 by 2 raised to the power n times that of the initial concentration. That means 1 by 2n into concentration A0. Now 3 assignments are given. Try to do these 3 assignments. The answers are there. If you get the correct answer as it is given in the textbook, that means you understood the half-life period and the derivation of the equation. Next is characteristics of the first order reaction. The rate of the first order reaction is directly proportional to the concentration of the reactant. That is, rate is directly proportional to the concentration of the reactant. When the concentration is doubled, fill in the blank question. When the concentration is doubled, the rate also will get doubled. 2. The rate constant of the first order reaction has a unit per time. That is, the unit of K is equal to per second, per minute or per hour. 3. A first order reaction obeys the following equation. First order reaction, we know about 3 equations depending upon the problem that what to solve it. You can use these 3 equations. Concentration of A is equal to concentration of A0 into e raised to the power minus kt. 2. K is equal to 2.303 by T log to the base 10, concentration of A0 by concentration A. 3. K is equal to 2.303 by T log to the base 10 A by A minus X, where A is the initial concentration and X is the amount which is already undergone reaction. Therefore, A minus X will give you the concentration at the time T. Fourth one, a plot of log to the base 10 concentration A against time T is a straight line for a first order reaction. Fifth one, the half-life of a first order reaction is independent of the initial concentration. It depends only upon the value of the rate constant of the reaction. That is, T half is equal to 0.693 divided by K. Last point, the time taken for the completion of any fraction of a first order reaction is independent of the initial concentration. Assignments are given here. Two assignments which are very important. This is an ISC question. Therefore, mathematical applications are there. Therefore, the determination of the order. For example, I already explained to you concentration of A raised to the power P, concentration of B raised to the power Q. This is the way the order of the reaction or the rate law. In this determination of this P and Q is an important factor that which you studied the mathematics. Those who are finding it difficult to solve this mathematics, please get the help of your mathematics teacher. This is because this problem is very important for the ISC examination. Those who are not taking mathematics subject always all the year, they finds it very difficult to solve these two problems.